All right, so let me recap. Quotient property, if you have n root of a over b, you can split it into two radicals, n root of a divided by n root of b. All right, so oh darn. I should have leave it as square root. My intention was leave it like a big square root of 48 over 5, and then I asked you to split, but I already split it for you, so go ahead and do this. Okay, so let me rewrite this. Here what I'm gonna do, I'm gonna cheat a little bit. So originally I meant like this, 40, so square root of 48 over 5. And then your job is to split it apart, right? Using this rule, right? So it's gonna be square root of 48 divided by square root of 5. Well, unless 48 divided into 5, then you simplify it right then. But because it doesn't, we split into 2 roots. Now square root of 5 is square root of 5. Nothing I can do. That's the prime. What about square root of 48? What can I do about square root of 48? If an even number, what do you divide it with? 2, right? So thank you. 48 to 2, 8, 24, right? And then 2 again, is that 12? And then 2 again, 6, and then 2, 3. So you got how many 2 here? You got 2 to the 4, which is 16, right? So 16 times 3. So 48 is the same thing as 16 times 3. So square root of 16 times square root of 3. Square root of 16 is 4. So this is old stuff right here, nothing new. And times square root of 3 over square root of 5. All right, you better know how to do B. B will be just what? You put it in. Well, A and B is a different letter. I don't know what A and what B is, a different letter, right? So according to the rule, I can change it into one big single root. So it's going to be cube root of A over B. That's it. That's it. It's kind of redundant. Why don't you guys try 2A? Try 2A. I'll do the B part, 2B. Again, a perfect root and a not perfect root. People at home, if you have the answer, you can put in the chat, please. Would you practice? For practice, yeah. You can practice. You're not the only one. Also, reason if you have 2 people, just gotta. So I think the problem is when you factor, you want one of them to okay, good. So you're gonna split 98. 49 times 49 times Do you guys have the answer? Let's see. Devin, she got 7s to the 5th square root of 2r over s square square root of 2r cubed. Maybe you can simplify more, Devin. If I was you, I'm gonna put it together first, because why do I put it together? I see 98 in the 2, there's a common factor with the 2, right? R to the first and R cubed on the bottom, and then S to the 10 and S to the 4. Those can simplify. You can do it later, but if I was you, I'll do it right now. So I want to simplify it right now as much as I can. So I'm going to put it under one root. So 98 R S to the 10 over 2 R cubed S to the 4. Bring under one root. What 98 divided by 2? Yeah, 49, right? And then R to the first and R cubed. Well, which one is bigger? Let me rewrite this to make it bigger. R, so 49 here on the top. 49. And then because I have R to the first on the top and R cubed on the bottom, you want to put the R in the bottom because they have a bigger exponent, right? So here, maybe don't write this down. You don't have to. I have R to the first on the top and R cubed on the bottom. So this is the same thing as what? R to the first on the top. On the bottom, I can write R times R times R. Simplify. So how many do I have? 1 on the top, right? So equal 1 over R squared. So that means R squared is going to be in the bottom, right? R is going to be in the bottom. And 1 on the top, I'm not going to write it. So 49 times 1 is 49. And then S to the 10, tell me what's S to the what now? Kobe, why don't you tell me what's S to the, if I simplify the S to the 10 and then S to the 4. Good, very good. S to the 6 on the top, right? See, you simplify a lot. Okay, now we simplify term by term. What's the square root of 49? You know, if you wanted to, you don't have to write this step, but if you wanted to, you can break it apart like this. I keep saying 48, I don't know why. Sorry, and add to the 6 over square root of R squared. If you wanted to, that step, you don't have to show me. All right, so square root of 49 is 7. What is the square root of S to the 6? The boot method, kick that 6 over. Yeah, there's the invisible 2 there, so 6 divided by 2 is 3, so S to the 3rd. And so square root of R squared is square root of R squared. R, right? R. You know what? I'm not gonna hold you responsible for the absolute value. I'm just gonna say, and make sure I'll say something here. Assume all variables are positive. So I don't have to worry about the square root. Do you have any question here? These are all review, right? These are all review. Nope, too big. All right, so B part is the cube. Now we allow negative under the odd root, cube root, fifth root, seventh root, right? So it's okay. Again, do you think should I bring it into under one cube root? Is a good idea? Why? It's a good idea, but why? Because we can, what can we do next if we bring under one root? We can, yeah, we can simplify, right? We can just like 2a. We can divide 98 into 2. Same thing here. Maybe, I don't know yet. Maybe we can divide 375 into 3. So, but even that, even if say hypothetically, if you can't, you can still simplify the y and the z, right? So a negative 375 y to the 4 z to the negative 2 over 3y to the negative 2 z to the 4. And now let's see, is 375 divided into 3? I think so. Yeah, it is. Okay. So negative 1 to 15 divided by 5 is 5. By 3 is 5. Negative 125. What about y to the 4 and y to the negative 2? What is that equal to? Careful. You careful. You got you in the right. You in the right track. It just the algebra is off. So if I have a to the n divided by a to the n is a to the n minus n, which is you in the right track. But remember, yeah, minus, right? So 4 plus 2 is 6. So y to the 6. And then z to the, now you don't want negative exponent on the top. So what do you think? Let's go ahead and do it. Let's go ahead and do it. I have z to the negative 2 over z to the 4. Say, using that rule, the one I wrote in black. So z to the negative 2 minus 4. So z to the negative 6, right? Over 1. And now what you can do, you can flip. Yeah, you can flip. So equal z to the what? 1 over z to the, yeah, z to the 6, which just means z to the 6 in the bottom. In the bottom. I'll tell you this, just because it's quick. If you move the letter, you move the power up and down, you should change the size. How's that? Does it make sense? To change the size. You move the negative 2 up top, you change the positive 2 and you add to 4. You move the negative 2 z down, you change the size, you add to the 4. How's that? Just if you move, you change the size. Right? Kind of like when you move between equation to left hand side and right hand side. Change the side. Okay. What is cube root of a negative 125? You have your calculator. You don't have to do it by hand. Maybe I'll show you how to do it again. If you have a graphing calculator, come on. It's just black. Oh, right here. Clear. So I have, if you want to go to cube root, you go math, 4 button down. Then cube root right there, number 4. Number 4. Click number 4. Something wrong, it just froze. Oh, wait a minute. Just won't listen to me. It's froze. What you got, Taylor? Yeah, negative 5. Okay, sorry, it's froze. So cube root of negative 125 is negative 5. Why? Because negative 5 times negative 5 times negative 5 is negative 125. And then cube root of y to the 6. Yeah, just the boot method, right? And then z to the second at the bottom. You kind of have this on your exam, kind of, right? This is just review here. So my advice to you, when you see the fraction like this, first thing first, ask yourself, can I divide the number on the top and the number on the bottom, right? Can I simplify within it? Then bring it under one root, simplify it first, and then simplify it more. If you can't, break it into 2 root and do separately. Okay, so do you guys remember this rule? The boot method rule thing, right? The n root of a to the m is equal to a to the m over n. The exponent is going to be on the top and the index on the bottom. So let me give you an example and you tell me how you change it. If I have, for example, Square root of 2. How would I change it into rational expression? I want to change it into like this. No more root. So be what?
2 to the 1/2 power.
Yeah, thank you. Was it Mike? Thank you, Mike. Mhm. Yeah, 2 to the 1/2 power. Because here is the power is 1, right? And then the invisible 2 out here we don't see. It's there. What about cube root of 2? Change into rational expression will be, yeah, 2 to the 1/3. 2 to the 1/3. And then fifth root, maybe last one, fifth root of 7 square. Corey, what do you think? 2/5. Thank you. So you guys know how to change between back and forth between the radical and rational, right? Good, very good. Oh, in my example, there's nothing to do with the rule. I guess I don't know why I'm gonna give it to you the rule for. But anyway, just know that maybe we use it later. Okay, so square root of 8 divided by square root of 3. 8 and 3 does not divide, so I'm not gonna combine. So I'm gonna do separately. So I'm gonna so what's square root of 3 is square root of 3. So square root of 8, I can break it into what? Which one is perfect root? Which one is not perfect root? Yeah, 4 and 2, right? Now square root of 4 is 2. Square root of 2 is 2 over square root of 3. You know what? No. I want we should rationalize the denominator. No, that's fine. It's no, I don't want to do like this. Sorry about that. I want us to rationalize the denominator. I forgot. So this imply, what does that mean? Rationalize the denominator. That mean we don't want root. We don't want radical in the denominator. We don't want root in the denominator. So let me give you an example. You don't have to write this down. So square root of 2. I want the radical to be gone. So the best way to do is what? Times with what? Times with root 2, right? So root 2 times root 2 is root 4, which is 2, right? So that we're gonna do. So that what we're going to do. If you see a root under the denominator, you just multiply with that root. Assume that that root is no longer simplified. If it needs to be simplified, you have to simplify it first. But let's do that. So the first one, square root of 8 times. I keep having typo. I'm so sorry. It should be just 8 over root 3. So I'm gonna say fix this. I'll remember later. All right. Okay, so I want to get rid of root 3. So what I'm gonna do, I'm gonna multiply both top and bottom by root 3. Well, 8 times, so when you multiply a fraction, you just multiply across. So 8 times root 3 over root 9. So square root 9 is 3, right? And the top to rewrite it. So now we don't have radical under the denominator anymore. That's what they want. Okay, now B, it is not wrong if somebody just jump in and multiply both top and bottom by square root of 40, right? Just like the same thing I do in part A. But if I was you, I wouldn't do that. I'll tell you why, because square root of 8 is in prime form, right? You can no longer take a square root of 3 without getting the irrational number. However, can I simplify square root of 40? Yeah, right? Because if I can simplify, therefore I had to simplify it first before I actually do that little do this thing right here, right? So let's simplify the square root of 40. 40 is what times what? Give me two smart numbers. Yeah, 10 times 4. So equal, so how do I do this? So equal root 7 over root 4 times root 10. Root 4 is 2 times root 10. Now, what do I have to times top and bottom with? Yeah, root 10 instead of root 40, right? The reason I'm doing this because if you times root 40 is too big of a numbers. So multiply both top and bottom by root 10. Well, root 7 times root 10 is, remember when you multiply two radicals, you only need it to be, the only thing that has to be the same is the index, right? Which is they are, right? They both square roots. The number, the radical doesn't matter. It could be anything. So 7 times 10 is 70. So square root of 70 on the top. On the bottom is 2 square root of 100, which is 2 times 10 is 20, right? I don't think you can simplify root 70, right? 35 and 70 divided by 2 is 35 times 2. 35 is 7. 5 no. They all primes. So it is okay to have a radical on the top as long as the bottom is 2 times 10. Yeah, my bad. Let me do one more step. One more step here. It's a square root longer. All right, C. Why don't you guys do C? I'll walk around, see how you do. People from home, please put your answer in the chat. If you have a question, please let me know. If you're shy. Is that all we have? That's all we have. Okay. The square root of 2y is simplified all the way? Yes. So all you have to do is multiply the top, multiply that. And then we got 2 square root of y. 2 square root of what you got? Good, Devin. I think that's the right answer. What you got, Taylor? Yeah. Oh, square of 2 times square root of 2 is square root of 4. Square root of 4 is 2. So you got the top right. It's kind of yeah, but yes, yes. And then you multiply across. So you root 8 times root 2 is root 16. So for the multiplication, as long as index is the same, you can multiply the 2 under the radical. So same index, you can multiply over the
Right, okay.
But for adding and subtracting, they would more picky.
So with adding and subtracting.
Same index, same radical.
Okay.
And then you only add what the coefficient. Instead of good, and the right step. Yes, simplify more. Do you want to? Yes, yes. So 8 times 2 is 16, root 16 over. Yes, 4. Yeah, 4. Okay, so you only be able to simplify the 16, but you won't be able to simplify the y.
Oh.
So the y is still under the root.
Okay, so
4 root y. So on the top. No. So square root of 16 is 4. Yeah, that's correct. So square root of y is still square root of y.
Oh, so. Because I don't know why.
Because what if it y squared, then yes, you can simplify with the root method. That's y to the first. So 4 divided by 2 is
Oh,
2 root y. Yeah. So just the root that you missed. All right. So you guys get the jig, right? So whatever under the denominator, you want to get rid of the radical. So multiply both top and bottom by root 2y over root 2 times y. Right? And now multiply across. On the bottom is what? It's square root of 4y squared. Let's do the bottom first. Square root of 4y squared, square root of 4 is 2. Square root of y squared is y, right? Y root method. Now the top, as long as you have the same index, which is they both square root here, you can multiply the inside. For multiplication division, they easy like that. So 8 times 2y is 16y, right? So be square root of 16y. What's the square root of 16? 4. Square root of y is square root of y, right? There's nothing I can do about that, so leave it alone. 4 divided by 2 is 2. You can simplify further. 4 on the 2. Okay. 2 here. So 2 root y over y. And do not simplify the root y and the y. Otherwise, you go back to the beginning, right? So far, so good. Yeah. So make sure you do your homework correctly. There's the answer in the back that you can check. By the way, when you do your homework, please show your work. I will not give you credit if you don't show your work. If you just give me the bunch of answer and it's 0, because I don't know where it come from. Right? I can just look it up the answer in the back of the book. Right? But show me work. Show me work. Thank you, Josh. Let's try. Okay, after number 2 and number 3, I'm going to take attendance, and then at the end of class, I'm going to talk about the exam 2, and then a little bit about exam 3, which is the good news for you. Okay, so 5/4 minus root 11. Do you guys remember the conjugate that I mentioned last time? Do you guys remember that? Anybody remember the conjugate? I think there's an R there. I don't remember. Is it conjugate? It's conjugate. Yeah. Anyone remember the conjugate about last time? Let me go back. Was it 8.3 or 8.4 or something? I don't remember what next section was that. It's 8.4. Oh, right here, conjugate. So what is the conjugate? Conjugate means the signs between two numbers is opposite. That's all. It does not mean x plus y is opposite of x minus y. Opposites mean what? Opposite mean this. Don't write this down. Opposites mean negative of x plus y, right? Just like opposite of 10 is negative 10, right? So you put negative in front of the number, but here you put the negative between them. So they're not opposite, they conjugate, right? When you change the sign between two numbers, they call conjugate. So note, let me remind you, conjugate again. Conjugate is, we change the sign between two numbers. When I say numbers, it can be numbers or it can be letters, right? It can be x and y or root 10, root 5. Okay, so the trick here to rationalize something like this, again, don't write this down, but do not do this. It's not true. Right? It's not true. If you have 5 plus 2/3 on the top, you can do what? You can do split. Oh, you can split into 5/3 plus 2/3, right? But it's not true. It is not true if you have 3/5 plus 2. You cannot do that. You don't believe me? You can plug in your calculator. 3/5 plus 2, it is not equal to 3/5 plus 3/2, right? So when you have addition or subtraction in the bottom, you cannot split. The reason I'm telling you this because people will split it, and then what they do next is they go into multiply the second fraction with what? Root 11, right? And then they just kind of proceed, but it's wrong. Do not do that. We have another way, it's called a conjugate. So tell me, what's the conjugate of 4 minus the square root of 11? Yeah, that's it. Times 4 plus the square root of 11 over 4 plus the square root of 11. You do that part, I give you 1 point on the exam. You're just doing that. I suggest you do parentheses around it. Let's take care of the top first. Top is easy. What can I do with the top? The top I can distribute, right? I can distribute. So 5 times 4 is 20. 5 times root 11 is 5 times root 11. What about the bottom? There are two ways of doing this. Either you FOIL it or you use the difference of 2 squared. Which one you want me to do? Do you remember? I'll remind you. Do you remember the FOIL method and the difference of square? Let me remind you. I'll go back to my lecture note. I believe 8.4 again. Right here. If you have 7 root sets, you have 2 conjugate multiplying with each other. The 2 way you can do. One way is you can do the FOIL. And then what happened with the FOIL is that it's the longer way. The middle term will cancel. And then at the end, you should have the answer is an integer. Integer. No more roots. The another way is you can use the square the difference of two square. So you can remember this, a minus b, a plus times a plus b equal a squared minus b squared. I like this one. I don't know about you. It's short. The less likely to make mistake. So what's a here? A here will be your 7. B will be your root 10, right? And you square them, subtract them, and you got the answer, which is the same. Right? So I'm gonna do the second method. Let's just recap. So second method, forget about FOIL. I'm not gonna FOIL. Not gonna FOIL. So what is my A? What's my B? What is my A? What's my B? Yeah. So let me just put a little reminder here. So here A is 4. B is root 11. So that means something square minus something square. Well, that A is 4. B is root 11. So I'm sorry, 4 square is 16. Right. Let's rewrite the top first. You know what I'm gonna do? I'm gonna do it like this because I don't feel like rewriting the top all the time. So I'll do it like this. Okay, so I got 16 minus, what is square root of 11 squared? Yeah, just 11, right? So square root and the two index, root methods. So 16 minus 11 is 5, right? So the bottom is 5. I forgot to tell you about one of them. Should I tell you now? No, I don't have to tell you now. Leave it alone. Then you're done. Actually, no, we're not done. What can we do next? On the exam, if you leave it like that, I probably take a point off. Because what can we do next is we can simplify, right? What can I factor out on the top? Between 20 and 5? 5, right? 5. So 4 plus root 11. Maybe I should leave it alone. I shouldn't distribute it. Maybe I shouldn't distribute it. But all right, I already did, so I'll factor it again. The 5, the on top and the 5 on the bottom cancel. So leave me, which is 4 plus root 11, which is totally legit. Why? Because as long as the bottom is no longer root, I'm okay, right? I can have root on the top because those are 4 plus root 11 over 1, right? And 1 is integer, so I'm okay. You guys try number 3. In the meantime, I'm going to take attendance. So try number 3. It's very much the same as number 2. And maybe don't distribute the top like I did. Maybe leave it like that. Oh, you cannot. When you add radical, they have to have the same.
Oh, because it's from the 5 square root 11.
Yeah, there's like 2 different things. All right, so you multiply the top bottom by 3 plus root 7. To do this step, I'll give you 1 point. Right. Put parentheses around it. And then the top, I'll leave it like that. Maybe I'll leave it like that for now. 6 times 3 plus root 7. The bottom, you're going to use different two squares. So it'll be 3 square minus root 7 square. 3 and then root 7. And then equal 6 times 3 plus root 7 on the top. On the bottom, I got what? Yeah, 2. Okay, 9 minus 7 is 2. All right, so I'm just going to say 2 here. Can you simplify the 6 and the 2? Yeah, right. That's why we don't distribute. So 3 times 3 plus root 7. If you leave it like that on the exam, that's fine. If you want to, you can distribute. So 9 plus 3 root 7. Maybe distribute. I think I prefer the yeah. I prefer. If you don't, it's fine. I guess I'm not gonna take a point off, but I prefer the last one. All right, the last one, and then last one. So what's the difference between number 2, number 3 versus number 4? Yeah. Go ahead. Mhm.
Oh, never mind. I forget about
Yeah. All right. What's the difference between 3 and 4?
sign on the
Yeah, they both fraction on the top, right, and the bottom. So that's the difference. But your way of doing things is the same. It's the same. So you multiply both top and bottom by conjugate of the denominator, which is yeah. Again, always the conjugate of the bottom. Okay, don't mess it up. And some people forgot and they do the conjugate of the top. Always the bottom. Okay, all right. Now the bottom is easy. You do they have the opposite side in the middle. So you do the different 2 squares. So it'll be something square minus something square. And that something now is what? What is A? A is, no, A is yeah, that's your A, right? And that's your B. So the whole thing, square root of n. And E is square root of 3. Square root of m squared is square root of m squared is n, right? Square root of 3 squared is 3, so n minus 3. The top, the bottom is easy, right? What about the top? I don't think you can use the different 2 square. They're the same size, right? So the only thing you can do is you FOIL it. So let's FOIL that. So I have root m minus root 3 times root m minus root 3. So FOIL it. Yeah, root m square. And then root m times root 3, I can write it under one root, right? Which is minus square root of 3m, or m times 3, but I like to say 3m. And then the inner, same thing, right? Same thing. Root 3 times root m is root 3m minus root 3m. And last one, negative root 3 times negative root 3 is, I know it's going to be positive. Yeah. And you can simplify a little bit more. So square root of m squared is m. So square root of 9 is 3. So the first and the last. What about the middle? They're not opposite. They only cancel if they're opposite. They're not opposite. Oh no, what I know the different than multiplication. This is if they have the same index and same radical, you add what? You add the coefficient. They're picky. They're picky. So because they have the same index, same radical, you add the coefficient, which is a -1 front. So be -2. Yeah, I think that's why people fail the exam. So that's your numerator. Let me write it here. M minus 2 root 3m plus 3. And nothing you can do about it. Please do not do this. Please do not do not simplify the 3 and the 3 here, and the m here. They don't work like that, okay? They don't work like that. Those terms are married. You don't want to break them up. You only allowed to simplify if they multiply. Right? If they multiply, then that will be your final answer.
Okay,
Mm-hmm.
so if that's square root of 3m, how come it's not
6m, the square of 6m, that what you asked?
well, no, how come it's not a invisible 2 in front of that instead of a 1?
Oh, it's not invisible.
Well,
It's not invisible. See.
Well, yeah, but like, wouldn't it be up there because it's a square root? I thought the 2 is always the sitting on the outside of that.
No, no.
So like,
what do you mean?
like if you have square root, I thought it was always 2 there.
Oh, yes. So index, I don't write, right?
Yeah.
So the index had nothing to do with the coefficient.
Oh, yeah, because it's the negative in front of it.
Yeah, so -1, -1, so -2. Right. The index just tell you that they have the same index. Mhm. And for adding and subtracting, they're picky. They're picky. You gotta think about how picky they are. They have to have the same index and same, everybody under the root has to be the same too. Right? And then you allow to add the coefficient. You don't allow to add those two under the root.
Okay, wait,
Mhm.
so if it was positive with
They
the
cancel.
coefficient, if like with the,
If like that, you mean like that,
yeah, if it was a positive instead,
then cancel. -1 from +1, they 0. They're done. But they're not.
I'll ask you about that.
Yeah. Okay. The only thing different, you can remember, okay, so let me go back to the denominator here. If you FOIL this out, don't write this down. If I FOIL this out, I'll use green. Root m times root m is root m squared, yes. Root m times negative root 3 is negative root 3m. And then positive root 3 times root m is positive root 3m. And then the last one is positive root 3 times negative root 3 is negative root 9. Well, square root of m squared is m. Square root of 9 is 3, so -3. What about the one? What about here? They cancel, right? Because -1 plus +1 is 0. So this is, I can say, plus 0 times root 3m. What's 0 times something? 0, right? So we use the quick way we say they cancel, right? The opposite, they cancel. Does that answer your question, Kobe? Yeah.
No, that's not
Yeah.
really what I was getting at, but
Oh, okay.
I was just confused about the exponent. I don't even know the terms.
The index.
The index.
The index,
is
okay.
usually 2, right?
Yes,
the
yes,
two
the
that
index
you
is 2.
don't always draw.
Yeah.
So is it addition or, because I know in one of them you would add the indexes together.
No, you never add index.
Never add.
Never add index, yeah.
Okay.
If for addition, maybe I wrote something here. Let me write something here in purple. For addition and subtraction, if you have the same index and the same radicand, what's radicand mean?
That would be the number.
Yeah, the number under the roots, right? What you can do next? You can add or subtract what? Yeah, the coefficient. Yeah. Only the same index. So for multiplication, and division, all you need is the same index. Then what you do that you can multiply or divide the radicand. Does that make sense? Mm-hmm.
But you would still leave it.
Yeah, still leave index intact. Yeah. I guess that's that's the answer to your question. But thank you for asking. Um, what I'm gonna do is I'm going to duplicate, move it over here. No, I have to. Okay. Right. So far so good. Do you have any more questions before I talk about the exam? No? Okay, all right. So I'm gonna stop.